Right now, we're moving, as you can see from the window behind me. And this is because of the fact that I use the accelerator to get up to speed. Right now, if I took my foot off the accelerator, we continue to move. This is because of Newton's first law of motion, which states that every object in motion tends to stay in motion. However, the later on in that same law, it says that an object in motion stays in motion unless acted upon by another force. Right now, we are starting to slow down. And that is because there are external forces acting upon my car. And that is air resistance and friction. There's friction happening between the road and the tires of the car. And that friction causes the car to slow down to a point where we've almost come to a complete stop. In a perfect world or out in space, if we got something up to speed, it will stay at that same constant speed up until it hits something. But here on Earth, we have gravity, air resistance, and friction, making that impossible and causing things to come to a complete stop.
As you can see, this chair is at rest. It is not moving. And it will continue to not move because of Newton's first law of motion, which states that an object at rest tends to stay at rest unless acted upon by another external force, such as my hand. So if I apply an external force onto this chair, it moves.
Newton's second law says that the force on an object is equal to its mass times its acceleration, which means that if we have two balls with a similar mass and we apply a high force to one, it'll fly farther. However, if we apply a lesser force to a similar massed ball, it won't fly quite as far. Newton's second law also explains why it's easier to move something with a lighter mass than a heavier mass, because the same amount of force applied to a lighter mass will have more acceleration, meaning it'll move more, such as this basketball. Whereas with the bowling ball, if I apply the same amount of force to it, it won't move barely at all.
Newton's third law says that for every action, there's an equal and opposite reaction. And that can be demonstrated through this cue ball and the 8-ball. When I roll the cue ball into the 8-ball, it's going to hit the 8-ball, making the 8-ball move. But the 8-ball is also going to hit the cue ball, and since the cue ball has some movement, it's actually going to almost completely stop when it hits the 8-ball. So as you can see, the cue ball almost stops while the 8-ball continues to roll. Newton's third law can also be explained through shooting a gun. When you shoot a gun, the bullet will fire out of the barrel such as this, which will create a reaction in the gun, pushing it back. This is known as recoil. So when I shoot the gun, you can see that the gun gets pushed back towards my body. And those are Newton's 3 laws. So I want to thank my girlfriend, my mom, and my dad for helping me film this video. I also want to thank my dad for letting me shoot his gun. And I also want to thank you for watching.